Hello, everyone. We'll just wait for a few minutes and then start. In the meantime, if you guys have any questions, feel free to ask. All right, I guess we can start. Yeah, a short recap. What we covered last 2 weeks, more or less. Um, Starting from classes, right? So essentially, a class is a blueprint of some form of uh, data structure in a way you can think. I would say data structure, but yeah, in this case, it's sort of like a we want to extend, let's say, um, C++ gives you inbuilt data types, like so you can represent integers, you can represent real numbers. But let's say you want to start representing complex numbers and more and further you want to have the special functions that come with it. So let's say norms, right? The distance from the origin to that complex number, so on and so forth. You can even add to complex numbers. You can have more and more functions. Okay, so something like that, right? So that's sort of the motivation, and you start. Um, sorry, and for that you declare member variables which represent the real and imaginary numbers. The norm function which represents the distance, right? That's what we just mentioned. More or less, the point is that a complex class, okay, you can define a complex class which will have all these members, okay, and you can declare different objects of it. So when you instantiate an object, instantiation of object is you can think of it like when the first time the object gets created. Okay, so I created C1, C2, so on and so forth, and these numbers then uh, do represent the complex number, and each of them have their own copy of the members. So the real and imaginary parts, it has its own norm function to calculate the square root and like so on and so forth. Okay, that's sort of the idea with classes. With constructors, that's the first thing that gets called when an object gets created. Okay, so for example, here if you pass C, like call C1 and pass 1 and 1.1, 2.0. Okay, so the constructor that is written in this manner gets called first. Okay, its job is to do some of the initializations and initial memory allocation and so on and so forth. Okay, here it's here it's defined to be with default values. Okay, you have real part, you have the imaginary part, and then these two normally you pass values, but if you do not, then it's taken to be zero. Okay. The second part of the constructor is you have the real parts, like here you can set values essentially. So what we do is we set the real member to the underscore real. So underscore real is basically what it gets from parameter passing. So like a function call. Okay. So similar for the imaginary part. Okay. Then the body, right? So that's the within the brackets. And we just had a line of print statement which confirms that the constructor was called. Okay. Next, the destructor. Essentially, you distinguish them by having the name of the class itself as function name. So that's when you know it's the constructor. With a tilde, it becomes the destructor. All right. So like previously, we had the norms also, like defined with the square root and so on and so forth. The extra thing we also saw is with the getter and setter functions, where you get some portions of the class exposed. Okay, so either so sometimes you don't want it to change the member variables of the class, so you just get the value. Okay, so you can return const values and so on and so forth here, right? Set function naturally will change the value, so you maybe sometimes just want a certain portion of it to be exposed, either way, either written or not, or just accessed. So in those cases, people write getter and setter functions, and you can do something like this. Okay, right? Um, yeah, that's sort of the summary for it. Inline functions essentially to reduce function call overheads. right? So that's when you replace, let's say, a macro or something. And so, for example, you want to call this function multiple times. So then that's when you set it as inline, so as to improve performance. Okay. Yeah, this is another class of called line. Okay, we defined it using the base, as I would say base. It's not derived class, but that's something we'll learn today. But we are sort of building more complex class or sophisticated classes based on the previously defined class. Okay, so the line function, the line class itself, okay, the object will comprise of two complex numbers. Okay, so the 2 points themselves, we call them as A and B, and then themselves become the members. Okay, defined as such, it forms a square with 4 line segments, and each of them having 2 points. Okay, all right. We also saw about again this, I guess we can say it. Yeah, we also saw about references. Okay, references essentially how you pass member variables and member function. In general, it could be just normal inbuilt functions, like inbuilt variables, inbuilt data types. Okay, those, or you can pass custom defined objects, so, or classes themselves. So these are uh, essentially STL vectors, which you can just pass and then modify those vectors inside another function, right? So that's sort of the idea. You do not want sometimes to copy the past vector and then copy back the modified result. You can just simply pass the vector with size already allocated and just modify that. Okay, so that's something called pass by reference, where essentially the code looks at this part and treats whatever you're passing A and B to be the same. Okay, at least for this call of the function. Okay, in the second call, it treats C and B to be the same. Okay, right. Usefulness again is you're reusing this code, defining it once with B, the name as B, and reusing it for all the A's and C's and so on and so forth. Okay. Now, that's sort of the idea with passing by reference. Remember, passing by value will look without the ampersand. And if you when you pass by value, then it sort of shallow copies A to B. So if A was A had memory allocated, it will allocate memory for B also. Okay, but it won't copy the values. You have to copy individual value sequentially. Right. Okay, so that's something. So pass by value, pass by reference. Essentially, these are the two kinds of passing to parameters that happens to functions. Okay, right. Last week, so this sort of the recap of classes. Last week we saw about class static members in a class, where instead of just a private member integer x, you define something called a static x. Okay. The nice thing about this is this static member is sort of shared member between all the objects of the same class. Okay. So, but one thing one has to remember, you have to define, uh, sorry, you have to define or initialize the member variable itself. Here it's just declared. Okay. In this part, yeah, you sort of actually allocate memory for it. Okay. Because for static, if there are multiple objects of the same class, how do we even know which member actually allocates memory, right? So sort of to avoid that, it's built into the standard that you explicitly define the member variable. And remember, to access a single value like this, you use the name of the class as the namespace. Okay, sort of like this. To use the data type. Okay, so since this is integer, you define uh, declare or set, okay, in this one line as integer, and then my class with colon colon x. Okay, so this sort of tells you that you are accessing the x inside this class. All right, and set it to 0. Okay, now after this is done, one has to remember that it only allocates memory once, sort of. Okay, in general, when you have classes, everything gets a copy. Private members, public members, for every object. Static members only once. Okay. And here it is. Just so happens that because of being static, everybody can access that memory now. Okay. So define one static, okay, and three member objects of that my class, okay. And let's say I call function print and so forth. This is something we saw last time. This sort of gives you an idea what happens to X when you set it in func, okay, and print in print, but you also update it. So depending on how many times you call, in what order you call ABC, you get different values, and you can run this code again to see uh, if what you expect from the output is exactly what you're getting. Okay. Essentially, the point being, understand the concept as when does the static work and how does it work. Very similar to that, we also saw this example where I had a data class, right? But another my class where this class itself is being used to declare three member variables, D1, D2, D3, all right? But now extra thing is that they're all static, okay? Now, because these are static, you have to declare them outside. So use the data type, okay? So here the class data becomes the data type itself, remember? And then you access D3, D1, D2, all of them using the namespace my class. Okay, that's what we have done here. And furthermore, because data class itself accepts uh, a constructor with a string, so you pass that to the constructor while actually uh, initializing the objects. Here we saw that the order in which you actually declare in static doesn't matter. Okay. Oh, so one more thing, the data and the destructor here keep track of when the ID that we're passing. Okay, so that's the second object, first object, third object. That ID gets constructed or destroyed. All right. So sort of to keep track of that, we uh, pass these strings. Okay, and what you will observe is the members themselves, in the order in which you actually set them, like as in declare them initially, does not matter when each of them gets created. It depends on when the actual initialization happens for that object. Okay. And similarly, there is destruction also. There's an order to it in which it occurs. Please feel free to run this code again, play around with the order in here. And if you have any questions, you can still like go ahead and ask me. All right. And the last thing we saw about was the THIS, the this pointer itself, which is essentially a pointer to the current variable, current object of that or instance of that class. So in any case, class, whichever objects calls it or whatever, then this pointer will always point to itself, right? So it doesn't have to keep track of its own pointer. So there's this pointer which is already defined in the standard. Okay, so you can use that. Similar example will be so you can access X, you can access this pointer, okay, and give the arrow operation and then access X. Remember, you have to use the arrow operation because in general, to access any object's member variable, use the dot operation. But if the object itself is a pointer, okay, so something like if instead of my class object, which is the object's data type, okay, you declare or you defined it in something like my class pointer object, okay, so it's now a pointer to object is now a pointer to my class. So I have to dereference that first, access the underlying my class class, okay, and then do a dot. So the dereferencing and the dot, okay, combinedly is sort of like the arrow operation. Okay, remember that so as to not make mistakes. So now because of that rule, yeah, to access the pointer's own data member, you use the arrow operation here like this. So this and then equals to okay. Okay. All right. Any questions so far? Okay. that case, I guess we'll start the next topic. Right. Okay. Before we start, so we'll be covering inheritance today. All right. The It's a very important part of classes, and what makes it very useful for in general classes, like handling them. So we'll see that. So before that, we'll talk about something called friend functions. Okay. So what we'll do is include stream. Okay. Then define my class. Okay. Remember with the syntax, classes end with a semicolon. Okay. Either way, when you try to compile, you'll get compilation errors, and you can fix it, but just remember the syntax. So we'll define a member data. Okay. And I'm not define its uh, segment. What I mean is it private, is it public, or is it protected? Can anybody tell me?
Public.
Sorry, I did not hear. Repeat. Hello.
Public.
No. So normally, remember, if you do not mention if it's public or private, right? It's private in C++. It may be a different case in other languages, okay? But in C++, it is private. Okay. You can explicitly, to avoid ambiguity, you can always specify it specifically, like have private and then so forth. Okay. That's I would say it's definitely a good practice, just to not get confusion. But remember, that is private. But thank you. That's a good attempt. So next, we'll make public part of it. Okay. Especially the constructor. Okay. Constructor has to be public because it has to be called outside the class. And if it can't, then anyway, you don't have a class. Right. Instance of a class. So the point. Maybe I'll just make it this way. So underscore data will become the temporary variable. Okay. I'll have a constructor written in this manner, and which essentially this is an integer, right? So it will set data from taking from underscore data. Then the constructor's own body will just print construct. Okay, constructor. Basically to say that yes, the constructor was called. Okay. Then just end the line. Okay. After this, in the public portion itself, okay, I'll declare something called a friend. Okay. A void function called display. So its data type is void, so meaning it doesn't return anything, but it means it is how do you call it? It's friend. The specialty of this is that it's the extra thing is that it is a friend function. We'll see what it means. Okay. So it takes my class and as object of it, okay, as a reference. Right. Then we'll define the display, okay, function itself with const my class outside, all right, which in itself will just print. So that's the hence this IO stream for it. All these print functions, data, and then a dot data. Okay. Normally, you do not have access to data, right? Outside the class, right? But that's the thing about friend functions. They have sort of like access outside, right? So that's sort of the idea. So let's see how it goes. My class A, we have to define some object, call it object, and pass, let's say, number 7 to it. Then we'll call display, okay, and pass object to it. Remember, display function itself takes my class data type as a reference. So we have to declare first define an object, okay, of this class, my class, constructor using the variable 7. That's what we're passing here. So as that it gets constructed, formatted a bit. Okay. Then the next thing is there is a friend function which has the variable display. Okay, as in the name as the display, which has a definition here outside. Okay. Now it takes my class, yes, but to access data of that member, okay, outside the class, you can make it a friend. Okay, if that function is a friend, it can access it. Okay, let's see that in action. Okay, normally because data is a private member, you're normally not allowed to access it outside. But if a function is friend, okay, it can access the member variables, even the private ones. Public ones anyway, the object can access, that's not a problem. Okay, here you need sort of a connection, right? So here the object A becomes the object, yeah, for this function. But for it to even access the member variables, right? Uh, the data member itself normally needs to be public, right? But here it isn't. Okay. Here it's explicitly we have ensured that it is private. But for it to access, okay, for display to access and print in a dot data, okay, that is allowed if the function is a friend function. Okay. All right. Another thing we have done here is you could have had the display defined everything here, but then one has to wonder, how do you call it outside then? Okay. So sort of like for that reason, the display needs to be in the scope of main. Okay. So we had the definition and so here you can think of it like it's just a declaration. The whole definition is here. Okay. When I say that declaration is here, it just says that there is a uh, friend function, data type void, name as display, taking parameters as this, okay, and that's it. Okay. Now, because of this line, it's just a declaration. Doesn't have a body. Okay. Body, when I say it is within brackets like this, right? The curly braces. Anything within that is sort of is what you call as a body for that function. Now, because that is absent, and we sort of have to have that, right, to do for it to do something, we declare it outside. Like we have that body outside. This is the declaration. All right. Any questions so far? Okay, moving on. Um, okay, so yeah, let's learn about inheritance. Okay. So in inheritance, okay, you so this is the key idea is that you have a class which acts sort of a base class, and from it you derive other classes. Okay. Now this is the sort of the idea. What does the deriving of a class mean? Um, what it means when a class acts as a base class. Okay, that's sort of the details, but this is in short what happens in inheritance. Okay, you have derived classes which get derived from base classes. Okay, so sort of like two, um, you need at least two classes to act as a base and a derived pair. Okay, so let's look at what makes them distinct, as in what acts like what, why do we call something as a base class or a derived class? Okay, so let's look at that. So first we will define something called a base class. So as to keep track of it will be easier. So I'll call that base class itself named as base. All right. In that, I'll define private temp member called data one. Okay. B. Oh, sorry. Public value. This part will be public. So integer data to B. All right. Now this is the third part that we haven't looked at yet, but it comes into play because of derived and base classes when you have inheritance. All right. So this property of object-oriented programming of classes, where you derive classes from another base class, is called inheritance. All right. So that's the idea, and then we'll see how each of the pieces get together. So we'll have data 3. Okay. So essentially 3 sections are there in a class. That does not change. Okay. So you have private part, which is the in private section. So there'll be the so for this case, it is just data 1b integer. The public portion, where this is the data 2b, then protected portions, which is the data 3b. Okay. All right. Next, derive something called derived. Okay. So you use the notation this way, call it as public. Okay. Base. So this is a derived class. Okay. In this, I'll define data 1b, bb, sorry. Okay. By default, remember this is private now, because in any case, here there is syntax for it that it is derived from base, but nonetheless, this is still a class. You have to, it follows all the rules for a class, which is it has a private section, it has a public section, it has a protected section. Nothing mentioned, so it is private. Okay. Public integer data to D. And protected integer data 3D. Okay. There's not much of a point in declaring this protected part, but in any case, we need more portions here. We'll define a function. Does not take anything. Doesn't return anything. It has some part in the body. So we'll use this operator access data 1D. It just accesses them. Does nothing. Okay. And moving forth, we'll also access do 3. Okay. And furthermore, after like data 1, 2D, like 1D, 2D, 3D, we'll also access the data member variables in base. Okay. So 1B, 2B, 3B. Okay. So that's what we'll do. Then we'll call the main function. We'll declare base as B, derived name as the class name is derived, right? So as call it naturally small d. Then access b dot data 1b. Okay. All right. b dot data 2b, 3b. Okay. Then so this is done. So then we'll have the uh, member, the object. Okay. D was the object for base. D is the object for derived. Okay. So B's we have so B's we have already, like that's one portion. D's will have another. Okay. Then we'll have more data members, which will be 1B, 2D, because these are the members here, right? 3D, okay. 3.3D. That's fine. Furthermore, we can also try to access the members of the base class itself. So that's where the idea of inheritance comes in. I'll explain one by one. Okay. Where you have, sorry. Yeah. So 1D, 2D, 3D, 1B, 2B, 3B. Yeah. I think that should be it. Okay. Right. Now, we try to define how the rules are for the inheritance, and then we'll go through each of these as to see what can be accessed and what cannot be accessed. Okay. All right. So I'll comment this whole thing for now. So this should compile in principle because I have commented some of the parts, so it should be okay. Great. Compiles without any issues. So far so good. All right. I'll first explain the rule and give you guys a chance to figure out which things will work and which not. And then we can go through them again. All right. Okay. So the rule goes this way. In any class, private members are always accessible by the member, by that object only. Unless it is static, okay? No other object can access that variable. So if it's private and I have an object B, okay, B is an instance of the base class called base, right? D is an instance of the class called derived. Okay, so B has its own copy of data 1B. Okay, the more objects you make, each of them will have their own copy, and that member variable cannot be accessed by anyone outside the class. That does not change. That is what a private member does. When you have public, it can be accessed outside the class. Okay, simple enough. The extra thing is when you have protected, that can be accessed by derived classes. All right. So that is the idea with protected. All right. Protected members can be accessed by derived classes. They're still private to the object. Okay. They're not public. They're not exactly private. Sort of somewhere in between. As in, if it is private, if it is public, then anybody can access it. Okay. If it is private, only the object can access it. But because something is protected, the derived class D, okay, here in this case, can access the member variable which is protected from the base class. And the syntax for deriving is derived class gets access from base. Okay, which means D here, okay, is sort of the object of a derived class from a base class B. There was a protected variable which now even D can access. Okay, here it's a private member. Okay, so again, the same rule. Private members can only be accessed by the same class. Public members can be accessed outside. And we used this pointer, which is basically says I'm accessing member variables of this class. Okay, of this object. This is a pointer of this object, as in for the derived classes object. Okay, you can do also something like this. Okay, here it means I'm accessing the variable of this class. Okay, here it means I'm accessing the variable which is from the base. Okay, here having a protector doesn't mean much, but you can always have it. I'll just comment it for now. It's basically like when you derive another class from using this derived class as an object. So then the protected will come into play. But anyway, that is fine. Let's just have it for now. It's okay. Okay. So now comes these statements, which will throw error, which will not throw error. Okay. And so basically I'll have all the things in screen. Okay. So try to work out which portions here will throw error if I try to compile them. Here, basically, I'm just accessing it. So accessing the data. All right. So whatever I've commented, some will throw errors and some will not. Okay. Try to work it out. Uh, and then I'll go through each of them and then try to give you the answers. Like, and we'll also explain why something works and why something doesn't work. Okay. To to give you guys whole part of the code, I just split it. Okay. Okay. So the right hand side says shows you which members are private and public and protected. Similarly for the drive class. Okay. And same thing. Uh, you use that and then do work it out as to what will happen for each of these. Okay. Do give it an attempt. It's okay if your uh, answers are incorrect also, but this is a good practice. Okay. It actually you'll understand how inheritance works. Okay. Yeah. Okay. I see some answers in the chat. All right. For others, since they're attempting, I will not reveal the answer yet. Yeah. You can explain why you think that should be the answer. Right. That's correct actually. So your answer is actually perfectly correct. All the explanation also are correct. Uh, Again, I'll just mention one thing. Okay. If you have all this uncommented, well, definitely the ones you mentioned, they will throw error. But can you tell me about these? If I come uncomment these two? Can you tell me why? Yes, absolutely perfect. So, um, any reason why others can be accessed, though? I know it's a very long question, but oh yeah. So what I'm asking is if the lines that I have commented, if I uncomment them, which lines will throw error? Right, that's correct. And others can be accessed because I know it's a bit repetitive. You have already answered it, but just yeah, the answer sort of lies. I understand the question might seem repetitive, but there's a motivation because these data members are trying to access data members. So sorry, these objects are trying to access data members from outside the class, whereas this is inside the class. So there still is a difference. Okay. Yeah. Your answers are perfectly correct. No doubt. I just wanted the explanation that so as to complete the answer. That's all. Right, that's correct. That's absolutely correct. Private is only accessible by the object itself. Protected can be accessed by the derived class, and public is accessible everywhere. So using only these three rules, we can do the whole question. Okay. Maybe I'll just give a few more uh, couple of minutes and then we'll go through each other. Well, I mean, the answers are already given, yes. And the rule that you guys have to use for this is also done. You can refer to the answer also. I'll just give it a few more minutes and then go through them individually. All right. All right, I guess we can move on to the explanations, right? So the answers are perfectly correct, as given by, uh, sorry, sir, Abhinya. Yes. Yeah. Hi. Yeah. Is it audible now? Okay. Awesome. Yeah. So, right. The answers are perfectly correct. So let's say, let's uncomment all this, right? So what you see is, yeah, I can refer this actually. So the private members are one, right, for the base class. So if I just see this one, this function can access this data 1D because it's a still inside the derived class. So data 1D can be accessed. That's fine. 2D, yes, it's public. It can be accessed everywhere, even inside the derived class. Data 3D, well, yes, because it's still protected, but inside the class. So that's not an issue. Data 1B, oh, okay. Now this one you have to be careful because this is a member which is private to the base class. Even if this like when you derive a class, right, you sort of get a copy of all the members, even the private members, right? But you can't access it. Okay, you can think of it that way. In any case, you can just remember or like understand it this way. Since it's a private member, you cannot access it. Okay. The second one, the two data 2B is public, so it can be accessed, not a problem. It's derived also. It can access in data 2B, not an issue. Data 3B, yes, it can access that also because it's protected and protected members can also get derived. Okay. Data 3B itself is like accessing member, not a member. So data 3B is the 3B that you're accessing from the derived class. Okay. And data 3B here will mean the member which gets sort of copied. Okay. So when you derive a class, it gets a copy of the base class and actually gets a copy of everything. Okay. Some are accessible, some are not. Private members are not accessible. Rest of them you can access. Okay. All right. And data 3D is just a new protected member. If derived itself gets derived again, so then it gets the into picture. But otherwise, for now, it might as well just be private. Okay. So yeah, if I compile this, yeah, there are warnings and one error. So that error is basically this one that we got what we thought of will be. So if we comment that private member, let's see, we get warnings. That's okay. Basically, it means why the company is saying is this because we did not use it anything. We just accessed it and did nothing with it. So just a warning, but nothing to worry about. Okay. All right. Any questions so far? Okay. Moving on. Now let's uncomment these, right? And let's go over each of them. So I hope this is clear that there's a sort of a difference in between these two. Okay. Here you're accessing the copy from the base class, right? And here you're accessing the base class's copy. Here you're accessing the base classes variable. All right. In these data 1D, 2D, and 3Ds, you access the members itself within the class. So not a problem. Here you cannot access even if the copy exists. Here you access the member because public anyway. So not a problem. Okay. You can also do it this way. That should be fine, I think. Yeah. Oh, 6 errors. Oh yeah, my bad. I should uncomment these, comment these first. Yeah. Yeah, no warnings. So you can also access the member directly. Okay, all right. Or actually, going further, you can also be more explicit. You can do this. Give the name of the base itself, the name of the class that you're accessing itself. Should be okay. Yeah. It's more explicit and clear as to what you're doing. Okay. So I'm trying to access data to be from the base class, the member that I've derived from. Okay. Here I'm accessing its copy that my class, my own class owns. Okay. So that's sort of the distinction here. All right. Okay. Sorry. Moving on. Now coming to here. Here it is mostly just access within the class. So you have more accesses you can do from a base class because any class will own all its member variables. So all of this will pass anyway. So you know that. Only now question is about the derived class when accessing the base classes variables. Okay. Then what how do we see? So there you have to go with the uh, sort of accessibility for each of the section. So private can't be accessed, public can always be accessed, protected can be accessed because if it's a derived class. Okay, that's all. Now to be is a copy. Now here it matters because remember derived class when gets derived from a base class, it creates all those member variables its own copy also. So you access to be data to be, which is part of derived class. So hence this pointer is accessing the data to be, which is a part of the derived class. Yes, it gets copied, right? And the access still exists because it's the public member. Okay. The access still remains because it's a protected member. And here we're accessing the 2B and 3B from the base class itself. Okay, so that's sort of the distinction. All right. Now moving on to this one. Here everything is a public, right? So you have to just see which can be accessed because they're public. That's all. Okay. So now running this, we get errors. Yes. And we can easily filter out which ones we will have. Well, we can do it ourselves also. Data 1B is private. So no, this will give error. 2B is public. Fine. 3B, we can't because it is not public. It's protected. You can't access it. Data 1D, no, because it's private. Nothing is mentioned. It is private. Okay. The data 2D is public, not a problem. Then data 3D protected, so we'll throw error. Let me just so far what we see is fine. So just 3 errors. Nice. Oh, yeah. Starting from data 3D, yes, expected to give error because it's protected. Okay, just so you guys confirm, or maybe I'll just do it this way. Okay, just have this one. Gives error, right? That's what we expected because it's a private member. Also, the compiler gives you the explanation for it. All right. Data to be public should be good to go. Sorry. Yeah, warnings, but then again, not an issue. No errors as such because public member, not a problem. The next one, protected should throw an error, right? Yes, it does. Okay, because it's a protected member. You cannot access outside the class. We'll have it commented. Private member should give an error. Yes, it's a private member. So we'll comment that. Going to 2D should be okay. Yes, that's absolutely fine. 3D, protected member should throw an error. Yes, it does. Okay. Going to 1B. Now we're accessing the 1B data of through the object of D. Okay. But the variable is private. So error. All right. Data 2B. 2B is public. So should be good to go. And the last one is protected member. Yes, it can be accessed, but not outside the class. Okay, so that's why the error. It can be accessed inside the class, but not outside. Okay. All right. So with all this, yeah, we'll have warnings. You can ignore the warnings, but this is essentially the idea. Which variables you can access where? Uh, inside the class, outside the class. All right. Okay. Right. Okay. Another example. Yeah, sorry about that. Yeah, another example. I have class base. Okay. Yeah, just everything we're keeping public or not. Okay. So void function in S F, okay, takes integer I, and in the body it will just print a cout. Mm, let's call it I. Okay, just prints I. Okay. Very similar looking. We'll have the function G. Okay, but this time it prints 2i. Okay. Very simple enough functions inside the class, and we'll have the derived class. Okay, from this. Okay, that's it. We'll just derive the class and not have any constructor, or we'll just assume the default constructor takes care of everything, and that's it. Okay. Now we'll call the main function. We'll initialize the base and derived class. So I can just write it. Okay. So first of all, we call on the base class f. Okay. Pass, let's say 6, and we'll call g, pass 10 to it. Okay. Now use the derived class as object d to call the f and g functions. It will pass 1 and pass 7 to g. Okay. Can you tell me what will be the output for this? Okay. 6, 20, 114. Okay. Now let's see the output. There is no static member. Did I make a mistake? Oh, my bad. Yeah, it's absolutely correct. Now, I know it's a very simple example, but the point I'm trying to make here is derived classes inherit. Okay, so this inheritance, what you're talking about, not just members. Okay, they inherit functions also. Meaning, if you have a function which is declared, which is defined only, which is defined in base classes, derived class has access to it. Okay, remember, it's it doesn't go the opposite way, as in I cannot access members which are derived in the base class, but derived class have access to all the members inside the base class. Members, both members, like member variables and member functions. In this case, I just had member variables. Okay, and in this case, I have member functions also. Okay, so these member functions I can access in my derived class because they also get inherited. Because these are public, I can access them outside the class. Okay. The same for this also. If it wasn't public, then even base class can't access it. Can't call them. Okay. Now the other thing is, other than, yeah, this is what the essential part is. Other than the member functions, you can access the member, sorry, other than the member variables, you can access the member functions also. Okay. So that's what happened here. I did not have to do anything extra. I could just reuse the fng functions defined in the base class in my derived class also. Okay. Right. That's I think straightforward. Okay. So yeah. Moving on to the next example. Okay. So a little bit about before we start the next example. Some details about. I'll just include the header file, string. Yeah. Some details about function overloading. Okay. Normally, when you have a function, let's say void function, okay, let's say it doesn't take any input. You have some body, which is body one. Like this one. Okay. Another function, okay, but this time it takes integer I, let's say. I have some body too. There is some code you have in the body that it's for now it's immaterial. It doesn't matter what we have. It does something with that integer. Now remember, I'm using the same name. Okay. What C++ allows you to do is you can keep going. You can have integer, you can have float, you can have double, you can have even classes. Okay. And this will be 3, this will be 4. Okay. All of this come under function overloading. What it means is the same function, depending on the input data type it takes, it will call the corresponding function. Okay. So for example, if I call function nothing, it'll use this body one. Okay. If I call function with passing 7 or 1, let's say integer, we'll call this body float. If you actually declare something as float and then pass it, then it will be this one, so on and so forth. Okay. Point being, essentially, these are all called come under the idea of function overloading. Okay. So we'll be using this idea, okay, now in terms of inheritance. Okay. If the include already done, so we'll define the base class. Okay. Public. Similar to what we defined previously. Okay. We'll have functions f and g that will have I. Maybe I'll just copy this too. Okay. Then library. Sorry. Any questions? Okay, I think we'll move on. Yeah, classes with derived definition. So we'll define derived class from the public class itself. It is okay. Define public void. This time it will. Yeah. Okay. So let's format. Okay. Okay. So now what? Sorry. What we saw before was public class inheriting f and g. Okay. That's fine. So basically, looks like this, where you do not have to define the same f and g again inside derived class. You already had defined it in base and just reuse that. Okay. Now, what we'll do is have f and g in base and also in derived. So this time I'll define integer I, okay, and have the exact same thing, but slightly modified this time. Maybe I'll say I is this, but I'll pass I minus 1. Okay, print that. Now I'll have B, okay, float stakes I, okay, and let's say friends 3i, because why not? Next we'll have H, okay, this takes double, okay, friends I, let's say by 2. Okay, yeah, this is also a class, so I have to end with the main function. Just give me a second. Yeah, so we'll have define the base, the derived. Okay. So declare these two objects from the base class, from their, sorry, not the base class, from the instance of their own class. Okay. Now we'll choose p dot f1. So here it will access this function, and then for we pass g, it will access the second one. Okay, so here we can just pass 4. That's fine. And the rest of them will access d. Okay, and let's say pass to d dot g. Okay, pass, let's say 6, and then d dot h, the pass 10. Okay, so yeah, then as usual, and you should don't write it, but why not? Return 0. So the important thing here to note is, okay, you guys can guess what should be the answer. Okay, so 1 and then twice of that is 8. Second one will be 2 minus 1, 1. Okay, 3i 18. Okay, and 10 by 2 5. Okay, yeah. So Right. One has to be a little careful as in what is the output. So I'll make a little remark on this F and G's. Okay. I think the answer should be correct. Yeah, they are correct. Um, Little note. Okay. So derived class can use the F and G's. I hope the okay, maybe I'll explain it and then we cross check with the answers again. So F and G are known inside the base. Yes. When derived class inherits the base class, it also has access to F and G's of the base and also the F and G, which is defined by itself. Okay. So the consistency should still exist. Okay. In this particular case, because a void data type F exists with uh, input parameters integer I, in both cases, for the derived class, it does not use the definition of this F. Okay. So this is called a function override. That's the spelling. Yeah, it's correct. Okay. You are overriding the definition which it was inheriting with your own definition in the derived class. So your derived class will use the F, the new F definition, not the old F definition. Okay. All right. Now, here it should be more clarity because both of them will print one. So yeah, yeah, better to yeah. So now I guess it's clear that it's actually taking I minus one, not I. Okay. All right. So this is function overriding where it inherits the definition of F, but since it has its own definition, it will use its own definition. Okay. So it sort of replaces, it overrides. That's what this property of of derived classes is. The second case, it has G with integer I. You have defined G with integer float. Okay. So this can coexist together. Okay. So for this derived class, it has only one definition I have, two definitions of G. Here in this specific case, as we saw before, this is called function overload. Okay. And H is new anyway, so that is absolutely okay. Derived classes can have extra functions which are not present in base class, and base class cannot access H anyway. Okay. So this is just new function. Okay. So now if you see the example, you'll have F, which will have one. So if you let's say pass one, it will use which definition? This or this? It'll use this one. Okay. Sorry, my bad. It is for base class. So base class has just two definitions, F and G. So it will use the first one, which will be one. Second one will be twice of that. So 108. That's correct answer, as mentioned by Abhigyan. Second one, that like this portion, which is for the derived class, when you pass 3, it will use this definition because it gets overridden. So overriding the function will give you the answer 3 minus 1, which is 2. Okay. Then with d dot g, it has access to both float and integer. Okay. So, but yeah, one has to be a little careful here. It prints 18, yes, because it automatically takes 3, as in it doesn't treat it as integer for some reason. Okay. So yeah, that's but one has to be remember it can have overloaded functions derived uh, it uh, overloaded functions from the base class. Okay, so here it prints 18. Okay, so and the third one H has the derived class has its own definition. So 10 divided by 2. Okay, that's what it prints, just 5. Okay, all right. All right. With that, I guess we covered inheritance today. Next class, we can try to cover, we'll cover more topics on typecasting. Okay. And Yeah. In the meantime, if you guys have any questions, you can ask. Else we can end today's class. Other thing I would say is again, what I sort of repeat myself, but yeah, the more you practice, the more you understand these concepts. So do practice more and more. Write code. It's okay if you are incorrect in the first attempts. It's absolutely okay. It helps you learn, and that's how you actually understand the concepts. So do practice. Yeah. Happy coding. Now, if you guys have any questions, you can ask. Else, you can feel free to leave. Yeah.